Number 11 is what we call a recursive sequence because of, see how we have the n plus 1 and the n? In simple terms, we call this one the previous and this one the next. That's a simpler way of looking at things. So to get this ball rolling, they give us a sub 1 is 5, so you can plug in the 5 right there. This means that you're going to be taking that 5, putting into this spot, so it's going to be 3 times 5 minus 4. We get 11. You can take that 11, put it into this spot again. 3 times 11 minus 4. So it's 33 minus 4, just 29. Then we're going to take the 29 and plug it in there. 3 times 29 minus 4. Maybe I should take out the calculator here. 83. Then 3 times 83 minus 4. So 245. A little tedious, but you just have to keep rolling over your answers. The next one, this is a little more challenging. Well, on the upside, the first term is always easiest to get. It's given to you. Now, here's the deal. If I'm trying to find a second term, things are a little bit different because of this guy right here. It's going to make our lives a little more uncomfortable. Now, let me ask you a question. What value would you have to make n so that it worked out? You can see that n would have to be 2 here and 2 minus 1, but 2 there. So I'm going to get 2 times 7 plus the 2, because for this one, n was equal to 2 right there. So 2 is in that spot. 2 minus 1 is the first term, which is that 7. Now, you don't have to get hung up on this is the previous, this is the next. That part was easy. It's this guy. What's n going to be? It's dependent on this one right here. So to get the second term, you're going to be using 2. So it's that. Let's walk this out. So it's 16. Then for the next one, you're going to get 2 times 16 plus n. Well, it's that guy right there. Which plus 3. So it's going to be 32 plus 3, 35. Now, for the next one, it's going to be 2 times 35 plus 4, because it's this one, that. $74. Then 2 times 74 plus 5. Just have to keep mindful that this and this are the same thing. Okay. Next. To find a sigma notation for this one, it's not as obvious. You'll actually see that question number 14 has an easier layout. Actually, if you don't mind, I'm going to do 14 first. 14, as you can see, it starts with 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed. So for this one, it kind of flows that I'm taking some number here and I'm going to be cubing it. Notice how we're increasing by 1 each time here. 5, 6, 7, 8, 9. So we start at 5 and we end at 9. And if you're not sure, plug the values in. Start at 5, 6, 7, 8, 9. Make sure it matches up to this right here. But this is the answer. Kind of straightforward. Number 13, on the other hand, it's not so obvious what it is, but check for a common difference. In this particular problem, there is a common difference when you go from here to here. So what you take is negative 4 minus negative 12, and then you end up getting 8. Now you'll notice that each time you're adding 8 for each continuous term. So since you're using the variable k, 8 times k. This common difference goes right here as a coefficient in front of the variable. Now the question is, where do I start? Well, if you're not sure where to start, I always found these problems to be best to start at 1. Going back at question number 14, it was a little more obvious that we started at 5, 6, 7, 8. This question is a little more challenging to see where you start, so it's easy if you just start with 1. Starting with 1, if you plug a 1 in for k, you would have gotten 8 times 1. So your first term would have been 8. But we're supposed to be getting a negative 12 for our first term. We need to make an adjustment. So what would you do? What would you add or subtract to 8 so that you got negative 12? And then you can see that the answer is going to be subtract 20. So to make this problem work, we have to subtract 20 right here. So 8k minus 20, that's going to work. We start at 1. How many terms do we have here? 1, 2, 3, 4, 5, 6, 7. So you have 7 terms. So you should be starting at 1 and ending at 7. But something very important you should be doing, that after you found out this rule, plug in the first one, make sure you got the negative 12. Plug in the last one, make sure you got 36. And you can even count up these terms to show that it does work. Okay, now this ends the review of the sequences. The next video will be talking about reviewing all the previous material from Chapter 5. That'll be in tomorrow's test.